Hello everyone, and welcome to another GIS remote sensing lecture video. And in this lecture video, I want to take our information that we know about digital elevation models, so that's the terrain, surface, and height model, and I want to sort of play a little game with them that can come in very handy when you're dealing with real-world data that you might not necessarily be 100% confident that you know which one's which. So let's talk about a question that comes up from time to time. So you have an elevation data set, and you don't know whether it's a DTM, a DSM, or a DHM. How can you quickly figure out which one it is? So let's go ahead and look at the question. You have three elevation data sets for the same region at the same spatial resolution. And I'm going to underline something right here. I'm going to underline this idea of same region and same spatial resolution, because you cannot do this otherwise. If they're the same region and the same spatial resolution, right? So you know you have one of each. You know you have a DTM, you know you have a DSM, and you know you have a DHM. But unfortunately, for some reason, when you downloaded the data, they weren't labeled to tell you which one was which. So the question is, can you determine? And what I want you to do is I want you to take a second. I want you to think back to this diagram here. Pause the video and just kind of think through this for just a second before we walk through it. Okay, so I asked the question, can you determine which one was which? The question is written is, how can you determine? So hopefully you at least, logically thought through the fact that obviously you can, otherwise he wouldn't say how. But maybe you've already kind of figured out how this would work. But just in case you haven't, let's go ahead and walk through it using the example diagram from before. So if you have three DEMs, digital elevation models, a DTM, DSM, and a DHM, and they're all for the same region at the same spatial resolution, how can you go about determining which one's which? Well, let's think about this for a second. If you look at one pixel, right? So let's say we have three. The three data sets. So we pick one pixel. So this is the same pixel in each image, right? So we're looking at the same piece of the image in each of the elevation data sets, right? So here, I'll just make sure that we are all clear here, right? We took a piece out, right? So this would be DEM1, DEM2, and DEM3. I want everyone to be perfectly clear what we're doing here. Right? If we were to look at this pixel in all three images, right? So because they're the same region and the same spatial resolution, right? These three pixels should overlap each other, right? They should be the same thing. So if we look at the values and we were to pull these values out, and we have one's 325. We know this one's let me clean that up just a little bit. We know this one's 325. This pixel value is 300. And this pixel value is 25. Right? So I just took the same numbers from our diagram down here. And if you remember when we walked through the diagram, right, we talked about, sort of visually why it would take this or why it would take that or why it would take that visually. But if all we have is the numbers, can we sort of retroactively reverse engineer, which one's which? And the answer is, well, of course we can. Right? Because think about it. If these three pixels represent the same feature, right? If these three pixels represent the same area in the same spatial resolution, so we don't have anything weird happening, right? It's pretty safe to assume here that the largest value is going to be the DSM. Right? And the reason we can say that is because the largest value is going to include the surface feature. So no matter what happens, right, for the same area, if you're including the surface feature, you're always going to have a value larger than if you exclude it, right? So your largest value, if you're comparing multiple data sets, the same pixel, right? So this is the same pixel. This is the same pixel for all three data sets. I don't want anyone to get lost here because I know this is kind of a jump. The pixel from the first DEM, the pixel from the second DEM, and the pixel from the third DEM, right? These should all line up in the real world because it's the same region at the same spatial resolution. I know I'm beating a dead horse here, but I want to make sure that you're not lost in what I've done. So I've taken these 3 pixels and I'm comparing the values. And I'm saying, okay, the largest one, right, it has to be the DSM because, again, right, it's including the surface feature, so it will always be higher, right, than the DTM. By the same token, right, the smallest value right, will always be the DEHM. Right, because again, right, if you think about it, the digital height model, that's the difference between the two. So if you're taking the difference, it's always going to be smaller than both of the others. Right, so that's this 25 meter here, right? And then finally, right, the middle value is the DTM. Right, so to recap and look at how can you determine, right, you pick the same pixel in all 3 images for the same area. Right, that's the key part. It has to be the same region, same spatial resolution. You look at the values and you find the largest one. That's going to be, that data set is going to be your DSM. Your smallest one is going to be your DHM, and then your one in the middle is going to be your digital terrain model, or your DTM. And again, right, because whenever you're including surface features, you're always going to increase your elevation because you're dealing with them. Whenever you exclude them, you're going to lower your elevation because you're not dealing with them. And then the digital height model is always the difference between the two, which means it's always going to be smaller than either one. So largest is always the DSM, smallest is always the DHM, and the middle is always the DTM. Again, hopefully this made sense. I encourage you to watch this video multiple times if you got lost with how I did this when I switched from talking about the data sets to comparing single pixels. I know that's a bit of a mental leap there. And as always, if you have any questions, please reach out. Thank you.